Great question here. The 9-digit positive integer n with this digit pattern is divisible by every integer from 1 to 17 inclusive. A, B, and C are distinct, so what are the values of A, B, and C? Now, the first thing to spot is that it's got to be divisible by 10, and any number that's divisible by 10 must end in a 0. So divisible by 10 implies B is equal to 0. So our number straight away becomes A0C, A0C, 0, 0, 0. And what we can then do is write that as A0C, A0C multiplied by 1,000. Remember, this is in digit form, and well, this is in digit form as well. And when I was doing this question, I didn't go the route I'm about to tell you. I kind of overcomplicated it. I looked into a few things, but then I started trying to divide by some of the more awkward numbers. But here's what you have to realize. We have a repeated little section here, A0C and A0C. So it's worth thinking about how on earth could we get that? So when we take a number like 11, if you do 11 times, say, 8, then we get a repeated digit, 88. And this can, if you then do like 101 times 8, okay, it's not quite repeated because it's 808. But if you times by, say, a 2-digit number, then you'll get 1 times 76, and then 100 times 76, you'll get 7676. So I'm trying to explain where this kind of thing comes from. So how am I going to get a repeated 3 digits? It's actually going to be from 1001. So if we do 1001 times a 3-digit number, let's say 257, then we'll get 257 by timing them by 1, and we'll get, doing 1,000 times 257, we'll give 257,000. So we'll get 257,257. And so what I'm trying to say is that this can be broken down even further into A0C times 1001 times 1,000. That is very subtle, but actually quite essential to being able to solve this problem. So let's just take a little look at where we are and see what numbers we know must go into this number that I've written down. So we know that 1 goes into it, no problem. We know that 10 goes into it because I dealt with that at the start, which means that 2 and 5 must also go into it. We now know that 1001 goes into it, so we need to find the factors of this. And again, this is actually something that it's worth learning, to be fair, because it comes up in these math challenges now and then. 1001 is actually 7 times 11 times 13. Quite a special number in that regard. It's got these distinct prime numbers. If you don't know that in this challenge, then you're going to have to try and find the prime factorization. We know that 2 and 3 don't go into it. The digits don't add, it's not even, and the digits don't add to a multiple of 3. It's clearly not divisible by 5. So the next choice would be to try and divide by 7. 7s into 10 go 1, remainder 3, then 4, so we get 143. And then 7 doesn't go into that a second time, but the next prime would be 11, and then 11s into 143 gives 13. So I can now write down that it's going to be A0C times 7 times 11 times 13. In fact, 1,000 is 10 cubed, so it's going to be 2 cubed times 5 cubed. I could write down the prime factorization. But my main point I'm going to make now is that we know that 7 goes into it, and we know that 11 goes into it, and 13. Is there anything else? Well, we know that 4 goes into it. I could have dealt with that one before, because 1,000 goes into it. And the same reason 8 goes into it, because 8 goes into 1,000. We don't actually know that 16 goes into it, because 16 doesn't go into 1,000. Because you can see from the prime factorization. Is there anything else? We haven't dealt with 3 yet. 14 goes into it because 7 and 2 go into it. Okay, so this is a good little, yeah, it's a good little place to consider the next part. So for the number to be divisible by 9, the digit sum must also be divisible by 9. And that means 2a plus 2c, because that's my digit sum, all the rest are zeros, must equal 9, or 18, or 27, or 36, and so on. Now, it's clearly not going to equal an odd number because I've got an even number plus an even number here, so I can rule out 9 and 27. I can divide through by 2, so a plus c will equal 9 or 18. Now, the only way it could equal 18 would be if a and c are both 9, but we know that they're distinct, so I can also rule out that one. And therefore, we know that a plus c must equal 9. Now, there's quite a few possibilities that will, we could have 1 and 8, or 8 and 1, 2 and 7, 7 and 2, so I'm not going to write them down quite yet. By the way, if it's divisible by 9, then it will be divisible by 3 and by 6, because it's divisible by 2, and by 12, so it's going to deal with quite a few of them, and 15. So really it's just 16 and 17 that are going to be the problem. So let's come back to 16. For the number to be divisible by 16, well, I know it's already divisible by 8, so I just need basically A0C to be an even number. Because if C is even, then A0C is a multiple of 2, and we've already got a multiple of 8 here, so we'll have a multiple of 16 overall. So that's going to help me out. Let's write down the possibilities for A and C, where C is even. So it can't be 0 because we've already dealt with that. So it's either going to be 2, 4, 6, or 8. Then A will just be whatever sums to 9. So 7, 5, 3, 1. And that's going to give me my number 702, 504, 306, and 108. Right, for these four, I'm going to guarantee divisibility by 9. I'm also going to guarantee divisibility by 3 and by 6. I was just saying this before. 12 is 4 times 3, so 4 goes into it and 3 goes into it, so 12 goes into it. And 15, because 5 goes into it and 3 goes into it, and I've also dealt with 16. So the only thing I have to do at this point is work out whether 17 goes into these numbers here. And there's no, well, there might be, I think there is a divisibility rule for 17. I don't know what it is, and I think it's quite complicated. So it's the best approach here is just going to be to divide. I'm going to write down my 17 times table. So this is going to give me 4. Okay, so I'm going to get 1 remainder 5. So it's not going to be 702 because 17 doesn't divide into it. About 504. Going to get 2 remainder 16. Okay, now I'm not sure what that is, but I know that 10 lots of 17 give 170, so there's no way that 17 goes into 164, so this doesn't work either. One remainder 13, 136. Okay, now if I double 68, sorry, then I will actually get 136. That was 4 times 17, so this is 8 times 17. So in fact, it's going to be 17 times 18. That seems to be working. Let's just see if it goes into 108. We need to just check all our solutions. I don't think it's going to. So if I add 17 on here, I will get 85. And then add on 20 and minus 3 gives 102. Sorry, that's not. No, that is correct. And then add on 17 again. Well, yeah, I can see. Sorry, I can see at this point this is not going to work. So got to be this 306. And therefore, what are the values of A, B, and C? I've got that B is 0, A is equal to 3, and C is equal to 6. I think I think I want to write that number down, this final number that's going to work. It's going to be 306, 306, 000. That number is divisible by every integer from 1 to 17 inclusive. Nice one.